Welcome back, chemistry students. Today we will be talking about your mole analogy project, probably one of the hardest projects in the chemistry class. Now, in order to do this project, you'll need a couple things. You'll need a calculator, a browser, and a free canva.com account. Once you have all of those things, you are ready to get started. Now, the mole analogy project is to take a mole, a number, and convert it down to a value greater than 1 but less than 500 million, or 5 times 10 to the 8th. That is because a mole is just too big of a number. Students can't wrap their head around just how massive 602 sectillion is. I mean, the number itself doesn't even fit on that line on the screen. That is how large a mole is. So in class, we all met and we read What If You Had a Mole, the number, of moles, the burrowing animals. And we talked about how that would cover the planet to 80 kilometers deep of just moles, and how it would actually be better to put it in space, where it would become an entire moon of moles, and all of the gruesomeness that would ensue. Now that would be if this project was done by a PhD student. I am not looking for you to do something that intense. Instead, I am simply looking for you to take a mole of something small and apply it to something massive. Like if you had a mole of marshmallows and you stacked them, how far could you go? Or if you had a mole of grains of rice, how many times could you fill the Atlantic Ocean? After years of experience, I can tell you, you would want to look up the world's ocean, as in all the ocean. Those are the types of things I'm looking for. So to demonstrate how to do this project, I thought I'd take a moment and do it in front of you in one of these videos. So I'm going to start with something small, being that it's the morning and you know how much I enjoy coffee. I'm going to say, what if I had a mole of donuts? How many donuts could I give every person on Earth if I had 602, or Avogadro's number, 602 sectillion donuts? Now, in order to do this, we are going to use the factor label method, which you learned about in Unit 1. So if I'm going to give one donut to all of the people of Earth, the question is, how many people are on one Earth? And this is why you'll need a browser. So typing into Google, what's the population of Earth? We get 8,005,167,000 and some numbers. So rather than use all of this, let's just convert it to scientific notation. Here's 10 to the third, 10 to the sixth, 10 to the ninth. 8 times 10 to the ninth people, so 8 times 10 to the ninth is our conversion factor. So we could use that conversion factor. 8 times 10 to the ninth people is 1 Earth. We could divvy out our donuts. So grabbing a calculator, we would type in 6.02 times 10 to the 23rd. Remember from Unit 1, we don't use the times 10 caret. You hit second comma, the number above the 7. In order to put that little e there, that e means times 10. So 6.02 times 10 to the 23rd times 1 over 8 times 10 to the 9th. And we end up with 75 trillion donuts. Every person on Earth would get 75 trillion donuts. Unfortunately, 75 trillion does not fit on this project. We have to get a number between 1 and 5 times 10 to the 8th. And so if we just finished here and said that every person on Earth would get 75 trillion donuts, you would fail the project. So we need to change our project. Okay, sticking with donuts and people on Earth, because I already did the research, let's tackle it a different way. Every person on Earth is going to get 75 trillion donuts. How long would it take every person on Earth to eat a trillion donuts? Let's rewrite this a little bit. To be honest, a lot of this project is going to be trial and error. You're going to have to revise your project as you work through it, because you will eventually do what I just did. Come up with a number too big or a number too small and have to either change where you're going or what you're filling or what you're doing with your small thing. Donuts. All right, so keep that in mind. Now, we're going to keep the research we already had. 8 times 10 to the 9th people are the people of Earth. This is our population. Now, if I'm going to figure out how long it's going to take us to eat our donuts, I need to convert people to time somehow. As in, how long would it take you to eat a donut? Now, when I field this question in class, people scream things like, a second! Realistically, if you had to eat 75 trillion donuts, 1 second per donut is going to be physically painful. So instead, I'll be generous. Let's say I give you 3 minutes. I'm going to give you 3 minutes to eat 1 donut. And now I have converted donuts to a unit of time. So in 3 minutes, all the people of Earth are going to eat a donut. For the sake of simplicity in this project, let's convert this. This many donuts the people of Earth are going to eat in 3 minutes. And then 75 trillion divided by 3 is still not going to be a very large number, so let's instead take it from minutes to years. Now, I do not know how many minutes are in a year, so instead, let's go about a different way. There are 60 minutes in 1 hour. There are 24 hours in 1 day. And there are 365 days in 1 year. In which case, we now can figure out, using these conversion factors, how long it would take everyone on Earth to eat a mole of donuts. So, we need to convert donuts to minutes, so we'll use the conversion factor. Since donuts is our previous unit, donuts go in the denominator because anything divided by itself cancels out, and we end up with minutes. Every 3 minutes, we're going to eat 8 billion donuts. Then, once we have minutes, we can convert minutes into hours. 1 hour is 60 minutes. Minutes cancel out. My answer right now is in hours, and I can take hours to days. There are 24 hours in 1 day. And there are 365 days in 1 year. Quick side note here, you'll notice the larger of the units, hours versus minutes, or days versus hours, is always a 1. So if you are filling something, or if you are going a distance and you need to convert from inches to feet or inches to miles, please Google or look up 1 mile is how many inches. Don't go the other way around. Don't say 1 inch is how many miles. You'll end up with crazy fractions. So with that being said, we can now do our math. So 6.02 times 10 to the 23rd times 3 over 8 billion. 3 divided by 8 times 10 to the 9th times 1 over 60 times 1 over 24 times 1 over 365. To give us 429509132.4. Or, here's thousand, here's million. 430 million years. if every person on Earth was immortal suddenly and had to eat one donut every minute, it would take us 430 million years to eat a mole of donuts. That takes the mole, a number you can't visualize, and converts it to something you could. 430 million years would be like dinosaurs' age ago. That's how long it would have taken all the people on Earth today, 8 billion, to eat a mole of donuts. That gives you some context. Now you'll notice that my final answer, I did not leave in decimal point or number form. I converted it to words. That's because in the end, you are going to create an infographic. In the library, we went over creating infographics on Canva. Canva, you can sign in with your NNPS web email address, and you can create an infographic by clicking on templates or searching for infographic. You'll select whichever one of these. All the pictures can be changed out, and once you've selected one, you'll come up with some cute little opening title and start your sentence. Every one sentence will start with, if you had a mole of, and then whatever you chose. So for me, if I had a mole of donuts. And then the next sentence, and every person on Earth ate one every 3 minutes. It would take us 435 million years to eat them all, assuming no one was born or died in that time. Now, one of the things you'll notice on the rubric in Canvas is that you have to have some assumptions, right? Every person on Earth has to become constant in order for this math to work. If you are filling something like the ocean, you need to say, assuming the ocean is this volume, and while that hopefully does not change, but if it did, it would ultimately change your project. If you are going to a location, all right, like a distant planet, planets' orbits are elliptical, so you need to tell me what distance, where in the ellipse, you are, all right? You finish the project by putting your name in the bottom right-hand corner and then having your math. Now, creating the math for this is going to require you to open up Word or Google Documents, and you can go up to the ribbon at the top, say insert, and then equation. This will open up an equation box, in which case you can type in your math. You can use the various operants in the ribbon at the top to make your math look nice and pretty and give me the actual answer. In order to get this into Canva, I have found the best way is to print your screen and then crop the image down. So if I hit crop, I can crop this image down to a more reasonable level, which makes it into an image which, if you copy and paste, you can place into Canva. And then you can resize it as necessary. Again, you'll notice that the answer is not the number, it is the number as a word. All right. You'll download this by hitting share, go to download, and download it as either a PDF. It's going to recommend a PNG file. It doesn't matter to me what you download it as. You'll upload it into Canvas, and the rubric is here. All right, as far as rough drafts go, as long as you have discussed with me what you are doing, which is usually the day after we're in the library, then you're fine. If you are absent this week, because this is the project we do before winter break typically, then you will be excused from the rough draft points. All right, this is just so that I can make sure I know what you're doing and you know what you're doing, and that's the project. The best projects from the class will get printed, laminated, and put up on our wall. That being said, this is, again, one of the hardest projects of the year. It will require lots of trial and error. You will probably have to rethink your project multiple times. All right, 2 examples are here, and follow your factor label method. You will be fine. If all else fails, send me an email or see me in class.